Hello, everybody. I just thought I'm gonna post this one video. So nobody of you came on, but that's fine. It's I think it's a reading day today for you guys. I just thought I'm gonna briefly show some of the slides that I wanted to show on choosing and reporting statistics. So this is chapter 18, and I also wanted to briefly make some comments on the final exam that we're writing on the 24th at 1 p.m. So we will have the following chapters for the final. So we will be reviewing chapter 7, the hypothesis testing, chapter 8, the confidence intervals. We will be going from 9, 10, 11 to single sample t-test, paired sample t-test, and independent sample t-test. Further, we will be reviewing ANOVA, analysis of variance. We only review one way within group and one way between group ANOVA. We will not be reviewing the two-way between group ANOVA. We further will be reviewing in the final exam correlation and linear regression, and the chi-squared test, chapter 17. Chapter 18 is not formally part of the final, but however, it will be the basis of what you all have learned over the semester. So we are essentially looking at the chapter on how to choose the right statistical test. 4 main categories are defined by Nolan and Heinzen. We essentially be looking at category 1, which describes the situation where we have one scaled variable. Category 2, where we have a nominal independent variable and a scaled dependent variable. And then we have the situation where we have only nominal variables. And lastly, the situation where we have only ordinal variables, which essentially we did not discuss in this class, which is what traditionally is referred to as non-parametric tests for hypothesis testing. So just briefly talk about category 1. Category 1 is the situation where we have 2 scaled variables. We are testing for associations using the Pearson correlation coefficient. We have done this in the respective chapter, and we have correlated absences with exam grade. So this essentially gives you one correlation coefficient, the so-called R, which essentially allows you to quantify the strength of a correlation. Then we have secondly, we have the linear regression, which essentially allows you to predict values on the dependent variable based on the independent variable, the magnitudes of the independent variable of each individual participant or data entry. We can also further amend this and using additional covariates in this regression models, which would then be multivariable regression. Category 2 is a nominal independent variable and a scale dependent variable, which essentially is the situation where we have several groups on the x-axis and we have a dependent variable on the y-axis. If we have the situation where we have a mean and standard deviation given from the population, we can use a set test. If we only have the mean given and we have to estimate the standard deviation from the sample, we are looking at a single sample t-test. If we have 2 levels of the independent variables as 2 samples and it's a within group design, meaning that we have before and after in chronological order, we will be using a paired sample t-test. Important is that there's an association between the participants and it needs to be the same participant contributing 2 data points. If we have 2 independent data points with 2 independent participants, the research design is between group design, and we would be using an independent samples t-test for this analysis. If we have 3 or more groups, in order to minimize the risk of multiple testing and the inflation of the type 1 error, we will be using in a between groups setting, a one-way between groups ANOVA. If we have the same participants contributing several repeated values, we will be looking at a within group setting, and we're conducting this as a one-way within groups ANOVA. Important is to keep in mind how to name ANOVAs, and they are named as a one-way, two-way, or three-way, or you can use even further nomenclature, sending a nomenclature in that same fashion. We're using participants in one or all samples using either between groups setting, a within group setting, or a mixed design setting. We have not formally done two-way ANOVA or three-way ANOVA or more-way ANOVA. We have also not done mixed design ANOVAs. I focused in class on the between groups ANOVA. The between groups ANOVA was, for example, that example about societies that would play the dictator game, the fairness with the allocation of fairness scores, and the within groups was the beer testing. And this is basically where you can use analysis of variance to do hypothesis testing. If you have, and this is category 3, if you have only nominal variables, then you have a situation when you only have one nominal variable, you can choose a chi-square test for goodness of fit. And if there are 2 nominal variables, we choose the chi-square test of independence, which both we have done. First example was the soccer players in Germany that essentially were born either in the beginning or in the end of the year. And the chi-square for independence was the second example we did in class, which was the paper cup labeled from a barista with either your correctly spelled name, your wrongly spelled name, or not labeled at all. So we can do chi-square test for goodness of fit or chi-square test for independence. I also wanted to briefly talk about the overview of reporting of statistics. So basically you have 3 main resources. One is the publication manual of the American Psychological Association. Then we have the API for Publications and Communications Support Task Force report. And this article I'm not familiar with. However, seems to be an article that was well mentioned for Nolan and Heinzen. What I wanted to note from my own experience, a very good book that also allows to learn and to review how to report statistics. And this is specifically for medicine, but I think this is generally applicable to various other fields and specialties. So this would be how to report statistics in medicine, annotated guidelines for authors, editors, and reviewers. So this is easy to find, and it's considerably cost-effective, I think. Good. So these are what I wanted to show you. Then lastly, when reporting statistics, so usually papers, and you will write numerous papers on the rest of your career. So when reporting statistics, you will use out of those 4 chapters, or sub-chapters that you usually have in a journal article, which is background or introduction, methods, results, and discussion, and usually followed by a conclusion. You will use methods and methods and results to essentially report your methodological approach and the results that you have gained from conducting those analyses. So essentially in the method section, you would indicate things like pre-registration, how you came to that sample size, so this would be the power calculation, how you did the sampling per se, what your analysis plan included as methodological approaches, and which statistics you essentially had used. Also, it will give information like alpha levels, software used. So there's various things that are being used. And then in the results section, you essentially describe the analysis and give the results of these analyses from traditional hypothesis testing and also the new statistics. The difference between traditional hypothesis testing and new statistics was that the traditional testing will be done with so-called p-values. As you well remember, everything smaller than 5% in a traditional one-time comparison will essentially be considered significant when less than 5%, with the definition that the differences you observed as extreme or more extreme as they have been found, as determined by the critical value, due to random chance or due to a systematic error. So if the p-value is small, they were found due to random chance and are essentially statistically significant. So if it's smaller than 5%, this was a systematic difference, and the p-value to have seen those with pure for pure chance are essentially smaller than 5%. Justification of your study will essentially be included in the pre-registration, and that will be found in pre-registration websites, and you also will have statements on how the data was collected and how it will be analyzed. Pre-registration, you also need, so we spoke about clinicaltrials.gov as a pre-registration website. Then we also talked about the sample size, which would be preceded and corroborated by statistical power analysis. Then we are stating exactly what had been part of the data analysis plan, including rules for discarding data, so the so-called inclusion and exclusion criteria. And then we would also include psychometric data for each scale used, like reliability and validity information. Then we're reporting in the results, the traditional and new statistics. We report hypotheses and tests conducted. We're stating the assumptions. We're reporting the traditional findings with the p-value and the new statistics using the confidence intervals. Then we need to keep in mind the compelling simplicity of graphs. So graphs are a wonderful tool to essentially present data and results in a way and fashion that a lot of information can be conveyed in a very intuitive fashion, and can essentially provide a lot of information in a very compelling and very comprehensive format. Lastly, then there are the open data practices. So this becomes more and more often seen nowadays. Some of the journals essentially do have policies on open data. That means if you are submitting an article, you are being asked to also submit the data, at least a minimal part of the data that is the core part of this analysis of your journal article and of your inferential statistics. And this would be in a de-identified fashion, of course, to maintain participants' privacy, and would allow for other researchers to reproduce your analyses. One of the journals, for example, that I would like to mention in this context is the so-called journal +1, that essentially has pretty much for most of the article data provided. So they have a very strict policy in that regard. So this is in case you want to take R for a spin. +1 is a journal you may want to have a look. Same with open materials. So if you, for example, you do checklists, so you follow guidelines, you would provide all these open materials with your submitted journal article, and you would essentially allow people to gain insight into your thought process, into your hypothesis derivation and hypothesis generation, and also in the way you conducted the analyses. This goes as far as that journals would, for example, also publish your codes, your R codes with your article. And pre-registration, we talked about, this is essentially when you register your trial or your study and analysis prior to essentially conducting and publishing it. Yeah, so this was all. This was all I wanted to show. I conclude, based on the fact that you have not come online, that everything is in the clear. If you have any questions, please email me, use the discussion board. And we will see on the 24th for the final exam. I wish you good luck. Please prepare well. So again, it's from hypothesis testing up to chi-squared, not choosing reporting statistics, and not the 2-way ANOVA. All the other chapters will be part of the final exam. 250 points. This semester there will be no extra credit, so please prepare well for the final exam. Good. So I will see you in 2 weeks and hope you're preparing well. And it's been a pleasure. And I hope you enjoyed the lectures as much as I did. And thank you for your vivid participation and your questions. And I wish you all the best with your further career. And I will see you at the final exam. All right. Bye-bye.